In this lecture, we are going to discuss insertion sort algorithm. Sorting is to arrange elements in a particular order. It could be ascending or descending. By default, we will take ascending order. Insertion sort need a variable called temp to hold a value during the process. The time complexity of insertion sort is order of n square. Now let us see an example for insertion sort. So this is my example 21, 4, 3, 36, 1. These are the elements in my input list and number of elements in this list is 5. So take 21, 4, 3, 36, 1. So 0, 1, 2, 3, 4. It starts from 0 and it will go up to 4. And the number of elements is 5. So in the insertion sort, we have to make two things. One is sorted sublist and the other one is unsorted sublist. Yes, I'll name it as S and I'll name this as US. So how to make the sorted and unsorted sublist? Always take the very first position as sorted list. So I'm taking this as sorted and all other elements, remaining elements as unsorted. So this is my sorted sublist. The sorted sublist is 21 and the remaining elements are in the unsorted sublist. And the next thing is, as soon as we do this, we have to take something called temp. Okay, as we discussed earlier, we will be using a variable called temp in the insertion sort. The very first element from the unsorted list will be assigned to temp. What is the very first element in the unsorted list? It is 4. So assign that to temp. Okay. So now this will be moved to assign to temp. As soon as you made the temp, what we have to do is we have to take the elements from the sorted list, that too from the last position from the sorted list, and we have to go up to 0th position and we keep comparing that value with the temp. So just compare 21 is greater than 4. Okay, if the element in the sorted list is greater than the element of temp, then increment the position of element from the sorted list by 1. Here 21 is greater than 4. It is true. Now what we can do is just move the 21 to 1. So what is here? 21, 3, 36, 1, and we don't know what is going to happen here. We just making this holder and just check whether any other elements present in the sorted list. If it is there, again you have to compare that with the temp value. As of now, in this scenario, there is no other element left out in the sorted list. So what we can do is that time you can bring the 4 here. Okay, if there are no elements left out in the sorted list to make comparisons, you can just bring the temp here. So this is the one iteration. So now what will happen here is this will become sorted and 3, 36, 1 will be in the unsorted list. So what is the next step? We have to make temp. So temp is what? The very first element from the unsorted list is what? Temp. It is 3. It is 3, right? What we have to do? As soon as you got the temp, we have to compare the elements in the sorted list with the temp, and that too we have to start from the last position of the sorted list. So what is there in the last position of the sorted list? This 21. Just check whether 21 is greater than 3. If it is true, what we have to do? Just increment the position. So as of now it is in 0, 1, 2, 3, 4. Now we have to increment the position of 21. Just 21 will move to what? Still we have this holder. 21 will be here. 36, 1. 0, 1, 2, 3, 4. And this is my sorted list and this is my unsorted. Remember that. So is there any other element left out on the sorted list? Yes, we have 4. We have to go up to 0th position. Now what we can do is just make the comparison. Still the temp remains 3. Okay. Check whether 4 is greater than 3. Yes, 4 is greater than 3. It is true. If 4 is greater than 3, what we have to do? Increment the position of 4. What will happen here? So here we have a holder 4, 21, 36, 1. Still temp has 3. You should not immediately put temp here. What we have to do is just check whether any other element left out in the sorted list to make the comparison. Any other element left out of the sorted list? No, it's 3. Just 4 is done. So we don't have anything in the 0th position. So that time what you can do is you can directly insert 3. So what will happen here? 3, 4, 21, 36 and 1. Now again we can make sorted and unsorted list. Now this is my sorted and this is my unsorted. Now what is the next iteration? What we have to do? Take the very first element from the unsorted list and assign it to temp. So now temp will become 36. Temp will become 36. 0, 1, 2, 3, 4. So what we have to do? We have to just compare the elements from the sorted list with the temp value. Just check whether 21 is greater than 36. Is it true? No. False. So that time we will not be incrementing the or we will not be checking the remaining values in the because already this is a sorted list. We need not compare the remaining elements in the sorted list. Okay. Now what happens here? 3, 4, 21, 36 and 1. Now this is my sorted and this is my unsorted. Once you make this, what we have to do? We have to reassign the temp. Now temp will become what? 1. What is the next thing? We have to take the elements from the sorted list and we have to keep comparing that with the temp until we reach the 0th position in the sorted list. So just compare whether 36 is greater than 1. True. What will happen here? So this is my temp. Okay, you have to increment the position of 36. 3, 4, 21, 36 will come here. So 0, here 0, 1, 2, 3, 4, 0, 1, 2, 3. We move the 36 to 4th position. Are there any elements left out in the sorted list? Are there any elements left out in the sorted list? Yes, we have 21. What we need to do? Just check whether 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 21 is greater than 1. True. If it is true, what we have to do? Increment the position of 21. So this will become 3, 4, 21, 36. So 0, 1, 2, 3, 4. What is the next thing? What we have to do? We have to check whether 4 is greater than 1. True. Then what we have to do? Increment the position of 4. What will happen? 3, 4. Sorry. We have to increment the position of 4. What will happen here? 4, 21, 36. We have a holder here. 0, 1, 2, 3, 4. Yes. Are there any other elements left out in the sorted list? Yes, we have 3 in the sorted list. So just compare whether 3 is greater than 1. Yes, true. So what we have to do? You have to increment the position of 3. So now it will become 3, 4, 21, 36. So 0, 1, 2, 3, 4. Just check any other element left out in the sorted list. No. Now you can bring 1 to the 0th position. So this will become 1, 3, 4, 21, 36, and this is my sorted list. Let us discuss the insertion sort pseudocode. So what will happen here? So we'll start from for I equals to 1. Why? Because we assume this as sorted and the remaining is unsorted, right? So we will not take 0. So I equals to 1, and it will go up to I less than n, I plus plus. And what we have to do, we have to take temp, we have to assign temp. What will be temp? So temp will be the very first element from the unsorted list. Here I equals to 1, so it is 4. Then we have to take what? Temp is a of I. Then we have one more variable called j. J is I minus 1. In the very first iteration, the j will become 0 because I is 1. Then we need to have a while loop to perform the operation. So what is the while loop? J greater than or equal to 0. So that is how the comparison works. And also, if a of j greater than temp, this is what we did, no? We just compared the element from the sorted list with the temp value. If it is greater, what we did, we just increment the position of j. That is what we are going to do now. Now, whatever, if a of j is greater than temp, as per this example, if a of 21 is greater than 1, what we did, we moved the 21 to the next position, that is j plus 1. Yes, that is what we are going to do here. So a of j plus 1 is equal to a of j, and we have to check the remaining elements from the sorted list. We should not stop. So we have to decrement j, and we keep doing until what? J reaches the 0. Once it is exhausted, then we can insert the value of temp over here. So this is how the while loop works. And after performing this, what we will be doing, just if all these condition fails, if j is not greater than equal to 0, and if a of j is not greater than temp, just make it a of j plus 1 to what? Temp. So this is how the pseudocode of insertion sort works. The time complexity of insertion sort, here the key operation is comparison, the number of comparisons that are going to take place. When it comes to best case, just look into this pseudocode. What happens here? If it is a best case, what is a best case? Elements are sorted. If it is sorted, just remember, it is going to make just n comparisons. Anyways, it has to make the comparisons. Every element with the next element has to make the comparisons. Yes. So it is order of n. Though the list is sorted, it has to make n comparisons. When it comes to worst case, when the input is reversely sorted. So if it is reversely sorted, what will happen? For every element, we have to make n minus 1 comparisons. Yes, for every element, we have to make n minus 1 comparisons. So it is n for n elements, we are going to make it for n times. So it is order of n square, n into n. For average case, again at an average, it has to make n comparisons for n elements. So again it is order of n square. Okay, so this is the time complexity of insertion sort. Thank you for watching this video.